Hello everyone, let's have another session about second routing LDP interworking. I think there are a lot of informations on the internet. You can read or see slides. Uh, Before I forget everything, maybe I just record and to share what we have uh, found with the LDP and SR interworking. So here is a scenario where on the left you have second routing domain, and then on the right you have LDP only domain. So this is strictly about interworking, not overlapping topology. For overlapping topology, there is a different behavior or solutions. So here is strictly interworking. That means second routing only, talking to LDP only. Okay, so let's start just first in one traffic direction, means from second routing to LDP. Okay. Here you could see the network topology, um, the 1, 2, 3, 4, 5, 6 router names, and then this guy is a ingress. It will be an ingress router, and this guy will be a egress router. You see that egress is in LDP, so this is a problem. The problem is this router 6 doesn't advertise its loopback as a prefixed. So those routers here in the second routing domain has no way to know that router 6 exists. So, okay, just again, we are talking about traffic direction from SR to LDP, okay? SR to LDP, okay? So what happens now is the solution is called mapping server. The mapping server basically advertise this loopback address uh, on the behalf of router 6. Okay, so it advertises a prefix it as a this prefix that is mapped to this prefix it, label 16. Okay. So once the router gets it, they believe that they have found the solution. Let's say, just take router 1 example. It just pushes prefix it 16 onto the packet and sent to its shortest path next hop. Okay, it's always the shortest path next hop. Let's say in this case that will be router 3. Router 3 is doing the same, just swapping the label, just like in a normal LDP second routing case, that per default you just use shortest path. Okay, so incoming label is 16 and then outgoing label is 16 and forward to our router 4. For router 4, because it's sitting between second routing and LDP, it basically do another kind of a swap. The incoming label is still a 16, but since router 5 is not a second routing capable router, the router 4 understands that, but he has a LDP neighborship between router 4 and 5. So that means router 5 will announce a LDP label mapping label to router 4. So let's say this is a label 30001. Then what happens is now router 4 is stitching that SR and LDP together. So this is happening automatically to do the label swapping. Okay. Once the packet get into the LDP domain, it will just be switched like normal case of LDP. So this is the traffic direction from SR to LDP. What is now coming is the other direction of the traffic from LDP to SR. Okay, so we're looking at the opposite direction for traffic return. So in this case, so sorry, maybe I just stressed this again. So this is the mapping server that for second routing. I forgot to mention, this message is advertised in a TLV, in ISIS, or in OSPF. So when the root 2 is configured as a mapping server, it just flat the message into the ISIS domain, so everybody understands it. Okay, this is how it got to know how this prefix is mapped to this prefix SID or the label. Okay, how to use the label. Okay. So for the other direction, in LDP, in for example this router, there is in LDP you have the ordered control and an independent control. What it means is either the midpoint router, the transit router, LSR, if it's in ordered control, then the LSR needs to wait for its downstream to send him or send it the label mapping messages. Once you get the label mapping message from downstream, then he could advertise that further to not advertise, to respond to the label mapping request. Okay, so that means the label mapping is always starting from the egress router. In this case, this is the 1 is the egress router because we are talking about traffic direction this way. Okay, so it needs to wait for the router 1 to assign the label, and that label mapping goes all the way to router 4, and then router 4 can start to announce that upstream. But you see in this case that router 4 is in second routing domain, so there's no LDP here. If you are using ordered control, that means this router has no way to announce the label mapping message for router 1. In this case, the prefix of 1111. Okay, so this needs to be changed if this border router is sitting between second routing domain and LDP domain. Then there's also a different mechanism in LDP, that's the independent control. Independent control is exactly the opposite. Router 4 can start to announce the 1111 prefix in LDP at any time, but it doesn't need to wait for its downstream. So in that case, automatically router 5 and 6 will get the label mapping message. He understands how to swap the label. So let's say this is 3001 for incoming label for the 1111, or maybe we should use another label. Let's say he assigned for the prefix 1111 a different label, let's say 401. Okay, then router 5 is using another kind of label, let's say 301 116. So this is the swapping, and then when router 6 gets it, he knows, okay, I need to send with the label 116 to router 5, and he does the label switching, and it arrives on this box. This box, router 4, says, okay, I don't have a label for LDP anymore, but I do have a second routing label. Let's say this is 11. Okay, so he does this label swap from 401 to 11, and then it happens here again from 11 to 11, and then at the end the label gets popped, and then router 1 will get it. Okay, this is how the other direction works. The important thing again is that this router needs to start to announce basically the label mapping message has to go through, has to start from router 4, although it's not the real egress router. Okay, Cool. Hope that helps. If there's any other questions, we can do next time. Cheers.